Next up, Chapter 6, Section 4, Elimination Using Multiplication. Try and solve all three of these systems of equations using multiplication. Press play when you think you have them answered. Okay, so when you look at systems of equations, the first thing you're going to look for is whether or not you have the same numerical coefficient for your x and your y. If you do not, then you can't use addition, you can't use subtraction, you have to move on to multiplication. Now, when you look at these, and you look at these coefficients, you're going to try and find a number that you can either multiply one of these equations or both of them by in order to get a common coefficient. Here, I see x as a coefficient of 1 and y as a coefficient of 1. X is a coefficient of -2, y is a coefficient of +3. So what I could do is I could multiply this top equation by 2, then I would have 2x's here and the x's could cancel. Or I could multiply by 3 and then I would have 3y here and I could cancel out the y's. I'll choose to cancel out the x's at first. So I'm going to multiply by 2, and when I do this, I end up with 2x plus 2 times y is 2y equals 2 times 4 is 8. The second equation I'm going to rewrite exactly as it appears above. And then I look and see, do I need to add or subtract? Since I have exact opposites here, 2 and -2, I'm going to add. With opposites you add to cancel. 2 and -2 cancel out. 2y and 3y, that's 5y. 8 plus 7 is 15. Divide both sides by 5, I end up with y equals 3. Now I can take this 3 and I can actually substitute it into any of these and it will give me the value of x. So I'll use the first one since it's the most simplistic. I have x plus y, which is 3, equals 4. Take away 3 on both sides, I end up with x equals 1. Now that I know my y and x, I can write my solution, x comma y, 1 comma 3. And if I wanted to check this, I could substitute these values into any of these equations and see if it works. 1 plus 3 was 4, that's what it's supposed to be, so it checks. Here, now when I look at these, not only do I see that I can't use addition or subtraction readily, but 3 does not go into 5 without a remainder. 2 does go into 4 without a remainder. So if I multiply this bottom equation by 2, I'll be able to cancel out the y's. If for some reason I wanted to cancel out the x's right away, what I'd have to do is multiply the top equation by this coefficient, the 5, and multiply the bottom equation by this coefficient, the 3. That would give me 15 x's on top and bottom, and then I could cancel the x's out straight away. But let's go for the y's. We don't have to multiply one equation in order to do that, so it seems a little easier. 2 times 5x, that's going to be 10x. 2 times 2y, that's going to be 4y. And 2 times 11 is 22. Now I can write the second equation right below it. And now I notice that I have exactly the same coefficient for the y's. When you have exactly the same coefficient, you're going to subtract. 10x's minus 3x's is going to be 7x. 4y minus 4y, it cancels. 22 minus 1, 21. Divide both sides by 7, and I end up with x equals 3. Now that I know what x equals, I can substitute it into any of these to get the answer. I'll choose the first one. So I have 3 times, where the x is, I'm going to write what it equals, 3, plus 4y equals 1. 3 times 3 is 9, so I have 9 plus 4y equals 1. I take away 9 on both sides, and 1 minus 9 is -8. Divide both sides by 4, and I find that y is equal to -2. So my solution set for this one, x was 3, and y is -2. The last one here, again, I can't readily use addition or subtraction to take care of this, so I have a choice here. Since 2 does not go into 7 evenly, and 3 does not go into 8 evenly, I can just get rid of either one by multiplying by the opposite coefficient. So I'll choose to get rid of these x's. Now here I have a coefficient of 7. In fact, it's -7. I could multiply on bottom by -7 if I want to, but I don't have to because I can use addition or subtraction. So I'm just going to multiply by 7. The whole goal is to get the number to match, not necessarily the sign. So multiplying this by 7, I end up with 14x minus 56y equals, and since the signs are different here, negative 224. On top, I have to multiply by this coefficient 2. I end up with negative 14x, the signs are different, it's negative, plus 6y equals, and 2 times 12 is 24. Now, since the signs here are opposite, I'm going to add to eliminate. 14x's and negative 14x's eliminates the x's outright. Here I have negative 56y plus 6y. That's going to put us at negative 50y. And here I have negative 224 plus 24. That's going to put us at negative 200. Now I divide both sides by the coefficient here, negative 50, and I end up with y equals, remember, negative divided by negative is positive, and 50 goes into 200 4 times. Now that I know what y equals, I can substitute it into any of these 4 equations. I'll choose the first. So we have negative 7x plus 3 times y, in this case y is 4, we just found that out, equals 12. Negative 7x and 3 times 4 is 12, equals 12. If I subtract 12 on both sides, I end up with negative 7x equals 0. Now, since I have 0 here, when I divide both sides by negative 7, anything divided by 0 is 0. So I know that x itself equals 0. Now that I have what y and x equals, I can write my solution set. So this one, the x value is 0 and the y value is 4. If you could do all those no problem, you should be set.